Good evening, everyone. My name is Shriya Agrawal, and today I'll be talking about the topic Internet of Energy, Connected Energy Ecosystem. Now, this helps in transforming power generations, distribution, and consumption through digitalization. Now, what exactly is Internet of Energy? Internet of Energy is integration of energy system with Internet of Things, AI, cloud technologies to create a connected, data driven, and energy ecosystem. Now, why this really matters is because it helps in real time monitoring of energy flows, predictive maintenance, reducing downtime, automated demand response capabilities, as well as enables decentralization energy markets. Now here we can see that if we have an energy device which is integrated with IoT using sensors and meters, the data that is collected by IoT is stored in cloud platforms, and these data are analyzed through AI and ML models to take any actions or any predictions. Now, why did we switch from a traditional grid to a smart grid? Now, a traditional grid has a number of problems, which some of them could be one-way power flow from centralized plants to consumers, centralized control with limited consumer participation, poor adaptability to peak demands and fluctuations, limited automation and manual fault recovery, and as well as carbon intensive with high dependencies on fossil fuels. Whereas a smart grid is a two-way communication between the utilities as well as the consumers or the customers. There is distributed generation with renewable integration. There's dynamic load management with real-time optimization. There's self-healing capabilities with automated fault detection and cleaner energy mix with lower carbon emissions. So we can clearly see that a smart grid is way more better than a traditional grid. Now, here let's talk about the key components of the connected energy ecosystem. There is smart meters and sensors, which is advanced metering infrastructures providing real-time data on consumption and grid conditions. There's distributed energy resources, which is DERs, localized generation from rooftop solar, micro wind turbines, as well as small scale hydrogen cells, energy storage systems, batteries, thermal storage, and vehicle to grid capabilities providing grid flexibility, and cloud and edge computing, AI analytics, distributed intelligence, and real time data processing at a grid edge. Now here let's talk about the advances in generation technologies in the current 2025. High efficiency solar panels, floating offshore wind turbines, and green hydrogen and small molecular reactors. Now, high grid efficiency solar panels captures sunlight from both sides, increasing the energy yield by 30% compared to traditional panels, perfect for floating and raised installations. Floating offshore wind turbines are harness stronger ocean winds on floating platforms in deeper waters, unlocking vast new areas for clean energy generation. And green hydrogen and small modular reactors, zero carbon hydrogen from renewable electricity, and compact nuclear solutions for reliable baseload power. Now, the impact of this is obviously lower costs through improved efficiency, higher flexibility in deployment locations, and easier grid integration with smart controls. Advances in energy storage. Now, there is next generation battery technologies in which there are solid state batteries with higher energy density and improved safety, long duration storage supporting 100 plus hours of discharge time, and grid scale lithium ion of redox flow batteries for utilities and application. Vehicle to grid integration. EVs serve as mobile storage units that can discharge to the grid, provides grid balancing services during peak demand periods, as well as creates new revenue streams for EV owners through energy markets. Now, digital technologies driving IoE. So there are basically three digital technologies, which is IoT, AIML, and blockchain. So, IoT, billions of smart devices measuring and controlling energy flows across the entire grid infrastructure. AIML is advanced algorithms enabling predictive load balancing, fault detection, and real time forecasting. And blockchain is secure peer to peer energy trading platforms and transparent billing with smart contracts. Demand side management and smart homes, real time pricing and automation. Now, there's dynamic electricity pricing based on grid demand, and automated appliances that respond to price signals, smart energy devices, smart thermostats with AI learning algorithms, intelligent EV charging during off peak hours, energy dashboard of real time consumption data, consumer empowerment, prosumer role. So prosumer is basically producer as well as consumer. So the prosumer can both use and generate energy, selling excess energy back to the grid during peak demand periods for maximum value. Now here we can see that there are multiple devices that are connected here. There's a smart thermostat, there's EV charger, there's energy dashboards that are shown. Now when there's energy required, the energy is taken from the grid and it is distributed among all these systems. But when there is an excess produce of energy, this can be sent back to the grid. That's basically the prosumer rule. Microgrids and decentralization energy. Now, what exactly are microgrids? Localized energy systems that can operate independently or in conjunction with the main grid serving campuses, hospitals, and remote communities. The key features are islanding capabilities during outages for resilience, seamless integration with renewable and storage, local energy control and optimization. Now, what are the real world examples? There's Brooklyn microgrid and Tata powered microgrid in both USA as well as India. Now, the Brooklyn microgrid, which is present in USA, is peer-to-peer energy trading platform using blockchain technologies enabling neighbors to buy and sell locally generated solar energy. And Tata Power microgrids are over 200 solar microgrids serving remote villages, providing reliable energy to previously underserved communities. Now, electric mobility integration. There's EV charging infrastructure, vehicle to grid technology, and ultra fast charging advances. We'll see what it is. So, EV charging infrastructure is smart charging stations with real time load management, dynamic pricing based on grid demand. Vehicle to grid technology is EVs providing grid balancing services during peak demand, and mobile energy storage for grid resilience. Ultra fast charging advances are next gen 350 kilowatt plus charging enables 15-minute charges, and AI optimized charging to extend battery life. Okay, now there are cybersecurity threats and data privacy threats in IoE. So here are some risks and how we can combat those risks. So in risks, we have grid infrastructure attack, data breaches and privacy concerns, and smart meter manipulation. So what exactly is grid infrastructure attack? Unauthorized access to control systems, SCADA vulnerabilities, and infrastructure sabotage. Data breaches and privacy concerns are consumer usage patterns, financial information, and personal data exposure. Smart meter manipulation is tampering with readings, billing frauds, and denial of service attacks. Now, what is the solution or how we can combat this is basically end-to-end encryption. Secure communication channels between all IoE components using advanced cryptographic protocols, zero trust architectures, verification required for all users and devices regardless of the location or the network connection, and AI based anomaly detection is machine learning systems that identify unusual patterns and potential threats in real time. So there are a few real world IoE projects that have been built, and we look at a few of them. Now, innovation IoE implementation are transforming energy systems globally through large scale pilots and commercial deployments. Now, the most famous three projects are European Interflex project, the India Smart Meter program, as well as Tesla's virtual power plant, which is based in Australia. Now, European Interflex project is testing flexibility services in smart grids across 6 European demonstration sites, enabling demand responses and DER integration. Now, in this project, there is a 23 million euros investment, and there are 20 industry partners that have been combined together. In India's smart meter program, ambitious rollout targeting 250 million smart meters by 2025, already improving billing efficiency and reducing loss by 20%. Now, there's a $21 billion investment in this, and 80 million meters are installed till now. And Tesla virtual power plant, which is based in Australia, is network of 50,000 Powerwall home batteries coordinated as a virtual power plant, providing grid stability during peak hour demands. Now there's a 250 megawatt capacity and 80% grid response. Now, what are the benefits? That we have four benefits as of now: is increased efficiency and reliability, optimized energy flows with real-time monitoring, predictive maintenance reducing downtime by 30%, automated load balancing for grid stability, reduced carbon emission, seamless integration of renewable energy resource, reduced energy waste through smart consumption, lower peak demand, reducing fossil fuel reliance. Cost savings, lower operational costs for utilities, reduced energy bills for consumers, deferred infrastructure investments through efficiency, and enhanced resilience. We have improve outage response and restoration, microgrids islanding capabilities during disruptions, as well as local energy independence and security. Now, we also do have a few challenges. Some of the challenges are high upfront costs, which is initial investment barriers for smart grids infrastructure, especially for developing regions, integration issues, lack of universal standards between devices, systems, and vendors, regulatory gaps, is policy framework lagging behind technological development. Now, the future outlook is by 2025, which is right now, there's AI powered grid management systems deployed globally. By 2027, there should be grid scale solid state batteries reach cost parity. In 2029, there is 75% of the EV 75% of EV support V2G capabilities as standard. By 2031, first 100% renewable smart cities emerge. By 2033, blockchain energy markets handle 30% of all transactions. And finally, by 2035, autonomous grid systems with self-healing and with self-healing capabilities. So our conclusion and call to action is that IoE is not just technology, it's a fundamental shift to more sustainable, participatory and intelligent energy ecosystems that will transform how we generate, distribute and consume power. The call to action can be invest in digitalization and interconnected energy system, accelerate renewable energy adoption and integration, engage consumers as active participants in energy markets, and prioritize cybersecurity in all energy connected systems. Thank you.